Hello everyone. We're going to start our discussion of conic sections with a review of circles. So to begin with, the standard form for the equation of a circle goes like this. A circle with a center of coordinates hk in a rectangular coordinate system and a radius of r has an equation of the following in standard form. X minus the x coordinate of the center of the circle plus quantity squared plus y minus the y coordinate of the center of the circle quantity squared is equal to the radius squared. So let's practice with a few of these. As you can see in example number 1, we do not have x minus anything or y minus anything before we square them. So the center of that circle would be 0, 0, the origin, and it would have a radius equal to 3, which when squared is 9. In example number 2, we can see that the x variable is subtracting 3, so we have an x coordinate of 3 for the center, and the y variable is, you can think of it as subtracting -2, so we have a y coordinate of -2 for the center of that circle, and the radius is equal to 5 because 5 squared is 25. Now what we're going to do, we're going to skip graphing these in the interest of time. Now what we're going to do is we're going to turn this around, and given the coordinates of the center and the radius, we're going to write the equation in standard form. So for number 3, that would go something like this. X minus -1, which would be x plus 1 quantity squared, plus y minus 5 quantity squared is equal to the square root of 2 squared, which is 2. Number 4, similar, and it would go something like this. X minus -2, which is the same as x plus 2 quantity squared, plus y minus 3 quantity squared is equal to 11 squared. As you know, when you have a circle written in standard form, you can easily identify the center and the radius of the circle. But in problems 5 and 6, we have the circles written in what's called general form, and it's not easy to recognize the coordinates of the center or the radius. So what we're going to have to do is we're going to have to put them into standard form. And to do that, that requires completing the square for both the x and the y variables. And to begin that process, I would recommend grouping the x terms together and the y terms together and moving any constants over to the opposite side of the variable. So I would begin this problem number 5 like this. X squared plus 6x plus y squared is equal to 27. Now we're going to complete the square for both x and y. So if you recall, let's do x first. If you recall, what we do to complete the square is write down the x squared term and the x term, and we are going to add half of the x coefficient squared to both sides of the equation. So half of 6 is 3. If we square that, we get 9. And we're going to write down y squared because it's still there, and 27 because it's still there, but we're also going to add 9 to the right-hand side. And we notice that x squared plus 6x plus 9 is also equivalent to x plus 3 quantity squared. Y squared can be thought of as y minus 0 quantity squared, and 27 plus 9 is equal to 36. So we can find the center of that circle now. The center has coordinates -3, 0, and the radius is equal to 6. In problem number 6, we're actually going to have to complete the square for both the x and the y variable, but it's going to work the same way we did problem number 5. We just have to apply the process twice. So Let's start by grouping all the x terms together, all the y terms together, and moving the constants over to the opposite side. So we would have x squared minus 8x plus y squared plus 10y is equal to 59. We'll start by completing the square for x, and then we'll complete the square for y. So x squared minus 8x plus half of negative 8 is negative 4. If you square that, you get 16. So over on the right-hand side, we're also going to add 16. And now we're going to complete the square for y. So y squared plus 10y. Half of 10 is 5. Square that, you get 25. So we're also going to add 25 over to the right-hand side there. And now we can write these in their factored form. So x squared minus 8x plus 16 is x minus 4 quantity squared. Y squared plus 10y plus 25 is y plus 5 quantity squared. And we have to add up everything on the right-hand side. And the easy way to do that is 59 plus 16 is going to give us 75. 75 plus 25 is 100. So the equation of our circle can be written as the following. 100 will write as 10 squared. So our circle has a center of positive 4, negative 5, and a radius of 10. And as you can see, there are some other notes here that relate circles to parametric equations and polar equations, but because of the limitations on remote learning, we are going to stop here. So at this point, I suggest you take a look at the homework in OneNote for circles and check your answers as you go along. They're at the bottom of that page.